Hello everyone. Today let's solve the problem circular RMQ. So you can read the entire question. They have mentioned the examples as well along with the input and desired output. So I'll just summarize the problem for you so that we will understand in a simple way. So just give me a second here. Yeah. First thing is what the question states. We are given a circular array where two types of operations are allowed. So we are given a circular array where two types of operations are allowed. So let's see what are those two types. So this will be the first one and this will be the second question. So second one. So we are given a circular array where two types of operations are allowed. First is we can increase the operation, nothing but here I can write in this way, increase operation, INC I'll just take, of LF RG and V. That's what they have mentioned here. We increase operation, we can increase all the elements in the LF and RG by V. So this one by V. So we have been given an increase operation where we can increase all the elements in the segment LF and RG. This one by V. So that's what they have given. This is first one. Second operation is range minimum query, nothing but RMQ. So range minimum query, I'll just take this one RMQ. So I can just consider RMQ of LF and RG, right? This one. So we will return the minimum value in the segment LF and RG within the array. So we have to return the minimum value within the range LF and RG, the two within the array. So that's what these two operations. So we are given a circular array where these two types of operations are allowed. I have explained these two. Next step is these operations are circular, meaning if you have an array, suppose if we have an array with n equals 5 elements or 5 elements, then operations with LF equals 3 array is said to be circular. If value n equals 5, I'm just taking the example. If LF equals 3 and suppose let's take RG equals 1. So suppose we are considering RG equals 1 and LF equals 3, then the elements with index 3, 4, 0 and 1 this with index 3, 4, 0, 1 get affected, right? So suppose the value of the element this one meaning if we have an array of this one size n equals 5, then we have the value LF equals 3 and RG equals 1, then elements with these index 3, 4, 0 and 1, other left index, right? The index that are 3, 4, 0 and 1 which are containing the elements will be affected. So we need to handle the multiple operations efficiently for the large arrays. So we have to handle the multiple operations efficiently by large arrays. So that's what we have to do. So let's discuss the approach and the implementation, and let's implement the code using the JavaScript or Node.js, right? So I'll just delete this one. Let's start discussing the approach. First step, as usual, I will be going with step by step. First step is always input reading or the input handling. So this belongs to the input. So we don't have to discuss this. So let's jump into the core logic. So first step is by this time you have to know input reading or the input handling. So it is same for most of the problems. So this you will see in the while we write the code as well. So initial thing in input reading or the input handling. So let's come to the main logic. So what we will be doing, we will be going with the this one, segment tree. So the approach that we'll be going for this problem is segment tree. We have to handle the this one, right? What do you say? Means we have to handle the multiple operations efficiently for the large arrays, right? For this reason, we'll be going with the segment tree. Also, we'll be implementing the lazy propagation as well. So why we are making use of the segment tree over here? segment tree is built to store the minimum value of the array segments. So we have to store the minimum values of the array segments, right? So for that purpose, we'll be making use of the segment tree. Also, why we are making use of the lazy propagation as technique as well. So along with the segment tree, we'll be going with the lazy propagation as well. So we'll be implementing the lazy segment tree, you can say. So the lazy propagation technique will be making use of it because to optimize the update operations. So again, I'm telling this one to optimize the update operations. So we have to optimize the update operations because the arrays are larger here, right? So we need to handle the multiple operations efficiently for the large arrays, right? For that reason. So to optimize the update operations, we'll be making use of the lazy propagation technique as well. So instead of updating the entire range immediately, the changes are delayed, nothing but lazily until they are needed. Only if they are needed, then what we are doing, we will be updating the entire range, right? So we are not updating the entire range immediately. Instead, the changes are delayed, nothing but lazily until they are needed. That's what we will be doing. So here, this will be lazy segment tree with nothing but segment tree with the lazy propagation that we'll be making use of. So third step is circular handling. So nothing but the circular behavior is managed by breaking the range into two parts. So for example, I can just consider this one. So this will be circular handling. So circular behavior is managed by breaking the range into two parts, right? Suppose for example, here if LF is less than or equal to RG, then it is normal range query or update, right? So it is normal range query. I'll just give NRQ if LF is less than or equal to RQ. So also if LF is greater than RG, then we will split the operation into two sub-ranges from LF to end of the array and from the start of the array to RG. So again, I'm telling if LF is greater than RG, we'll split the operation into two sub-arrays. First one is LF to the end of the array. Nothing but here, LF to end of the array. I'll just write E, and also from the start of the array, I'll just take as a start of the array to RG. So this one we can split into two parts, right? So just give me a second here, these two parts. So yeah, this is the this thing. So we'll be getting the output here in the third step. So we have to display the output. For displaying the output, we'll be making use of the console log as we are making use of the JavaScript or Node. So we'll go with the console log to print the result or display the result. So this is the approach that we will be going with for this particular problem. So I'll just remove this one. Let's start writing the code so that you'll understand the problem better. So this is the best problem to understand the lazy propagation. This one, lazy segment tree basically. Segment tree implementation with lazy propagation actually. Let's see step by step, right? So first, let's start with the input handling. Let's import the file system module to read the input from the standard input. So I'll just give fs equals require of fs. So this is fine. Next, let's read and splitting input into the array of strings. So we have to read and we'll set this one character to UTF-8. Also, let's remove the white spaces. Also, let's split this one based on the new line and carriage returns. Nothing but we'll be splitting this one as we need to read the input line by line. So I can just write in this way. Instead of expanding, I'll just write here fs dot read file sync of, let's start with the 0, and we will set the we'll set this one to set the encode into UTF-8. Also, then to remove the white spaces or the spaces, unnecessary spaces, I'll just make use of this this one, trim. To read every input line, I'll just make use of the this one, a regular expression over here. So I'll just give /n/r. This is same for most of the problems, right? If you have followed the previous problem, by this time you have to know the input handling actually. So next, after this step, let's initialize the counter to track the reading lines of the input. Initially, the count of the input lines will be 0. So this is one thing. After this one, let's make use of the custom function, nothing but the custom helper function, to read the next line. We have to, after reading the first line of the input, we have to read the next line as well, right? So to read the next line of the input, we'll be making use of the helper function also, and we will convert it to the array of integers. I can just give here, I'll just take the function name read num. Yeah. So how can I write this one? Input of, to move to the next line, I'll just write count plus plus. Also, suppose if there are numbers here in the same line, if there are distinct numbers in the same line, we need to treat those numbers differently, right, by the space. So I'll just make use of split over here for that operation. And also we need to map all the this one, right, input. So I'll just consider a here. This one will be plus a. So you can just consider any character. I have just took the a. So you can consider str or string, anything over there. I have just considered a. So this is it for the input handling. So next, let's write the lazy segment tree class definition for managing the range minimum query and the update operation. So here, let's start this one. Lazy segment tree class definition for managing the, again I'm telling, for what reason we'll be making use of the LST or this one lazy segment tree class for managing the range minimum query and the update operation. For these purposes, we'll be making use of LST class. So here I'll just write class lazy segment tree. It's just the class, right? Let's start with the constructor. So why we are making use of the constructor? To initialize the tree as well as to set up the necessary structure. So we need necessary structures as well as we have to initialize the tree as well, right? Segment tree. So that is the reason we'll be going with the constructor. So I'll just give here constructor. The parameter I'll just consider array here. Next, I'll just let's initialize the size of the array. This will be this of n. I'll just set this one to array length of the array. So this is first step. Next, let's calculate the size of the segment tree. So just give me a second here. Yeah, let's calculate the size of the segment tree as power of 2. So for the power of 2, let's consider in this way. Or you can go for math.power as well. I'll just use in this way. I'll just give this dot size equals 1. This will be math.say. Let's consider math.log 2 here. This one will be within this dot n. So I hope this is correct. Let's see. Just give me a second over here. Here we have considered 3 braces, right? Why we are getting here? Let me close this one. So yeah, we are calculating the size of the segment tree based on the power 2, right? So next, we will write the function to combine the results. Nothing but we have to find the minimum, also maximum, right? So how can we find the minimum? So I'll just make use of this one, math.min. So I'll just keep this dot form to, let me set this one to math.min. I hope this works. Next, we'll set the default value for the unused nodes. So the nodes which we are not making use of, will set the default value for it, nothing but infinity for the minimum. So I'll just consider here this dot default values, right? So I'll just give default equals, we'll set this one to infinity. So this is fine. So next, after this step, let's declare the array to store the segment tree nodes. We have to store the segment tree node somewhere, right? For that, we'll be making use of the array. So we'll declare the array for it. So this is, how can we write this? I'll just go with the name data and I'll just give new array of 2 into size. For size, I'll just consider this dot size. and let's of size 2 into size, and let's fill this one initially with infinity. Nothing but infinity is nothing but this dot default, right? So initially this has to be this dot default. So after this, we also need to declare the lazy array, right, to store the pending updates. So whatever the updates that are pending, that we are storing that one in the this one, what do you call, lazy array. For that one, I'll just declare this one, this dot lazy. This will be new array of size, same thing, 2 into size. This one we have considered size actually power of 2, that we have considered this one here. Here we have initialized this dot size to this one, right? We are just making use of the same thing over here. This dot size I'll write here. Let's fill this one initially with 0. After later we can store the pending updates with this one in this array. So finally we will build the segment tree from the input array. So I'll just give, so let's make use of the process here. Process of, we have made use of the array, right? This one, this array. So yeah, I'll just remove this one. Yeah, this is fine now. After initializing the constructor for the tree and setting up the necessary structure, let's write the method to build the segment tree based on the input array. Let's write this fast. This is simple. I'll just give process of array. So here let's initialize the leaves of the tree with the input array values. For that I'll just make use of the for loop. I'll just give let I equals 0, I less than size nothing but n, this dot n we have considered, right? So let's increment the I. So let me come here, this dot and sorry. So yeah, so here I can give like this. So data, this has to be this dot size plus I, iterated value. This we will set this one to the iterated value of the array. So array of I. So I hope this is clear. Next step is, after doing this, we have to build the tree by combining the child nodes using the specified function, nothing but minimum in this case. So again, let me consider the for loop itself. Let I equals, I can just consider this dot size -1, also I greater than 0, and reverse iteration in this case. So we are just building the tree by combining the child nodes using the specified function, nothing but minimum in this in our case. So same thing, I'll just give iterated value of data, nothing but this dot data we have considered, right? So here this will be this dot func. FUNC we have considered here, I think. Oh, this has to be FUNC, sorry. That is the reason this is not showing here, right? Suggestion. Just give me a second here. Why this is stuck basically. Just give me a second. What happened here? So yeah. Now within this this dot function we'll be considering data with the size 2 into I. So this has to be into 2 into I within the array. Also the previous value, nothing but we can next value, sorry, this has to be this data of 2 into I plus 1. So I hope this is clear. So next step after this one, we will be writing the helper method. We'll be making use of the helper method, nothing but push. I'll be making use of the push just to propagate the lazy updates to the children of a node. So this one we had discussed. We will be writing this one fast. So I'll just make use of push of index over here. So let me consider this one, this dot index of 2 into this will be index itself, index again plus this dot lazy of the same thing, 2 into index plus this is just index, right? Lazy of index. I can just write in this way of index. This is fine. We are passing the lazy value to the left child. Next, after passing the lazy value to the left child, we'll pass the lazy value to the right child. So I'll just copy the same thing and make the necessary changes. So I don't want to type this again. So here this will be this dot lazy, same thing. So why this one is this dot index I have given. This one has to be lazy. So this one as well. This one has to be this dot lazy. 2 into index. This time it's index plus 1. So this same thing. Next, we will update the data for the left child. So we'll be updating the data for the left child as well as we'll be updating the data for the right child. So let's write for the left child and make the necessary changes for the first write for the left child and make the necessary changes for the right child, right? So I'll just write in this way, this dot data. It has to be 2 into index. Had to be this data of 2 into index plus lazy of the index, right? So we can write in this way, lazy index. So I'll just copy the same thing and make the necessary changes for the right child. So let me copy this one and let me paste it over here. So just give me a second. What happened here? So yeah, here I can write this one, this dot data for the right child. This will be plus 1 as well as here this one remains same, lazy of index, right? So after this one, let's clear all the lazy value for the current node. I can just write here lazy index. This one, let's set this one to 0. This is fine. I hope this is fine. Next, this is just the helper method to propagate the lazy updates to the children of the node. So we saw for the left child and the right child, right? So first is passing the lazy value to the left and right child and updating the data for the left and right child. Finally, we will clear the lazy value for the current particular current node, right? So this lazy of index will set this one to index 0, the value 0 finally. Next, after this, we'll write the method to update the parent nodes after modifying the tree. So after modifying the previously we went with the child nodes. Now we will write the method to update the parent nodes. So we have after modifying the this one left and right this one nodes, right? So we have to update the parent nodes as well after modifying the tree. So for that one, we'll be making use of the build. So I can just write here parameter. I can just take index over here. So we will move up the tree and we will update the parent nodes. So I'll just consider while loop. Index should be always greater than 1. So for this one, I'll just be making use of the while loop. So index I can consider like this. And let's combine the results of the children and add any pending lazy updates. So for pending lazy updates, so we are making use of this one, if you remember, lazy, this one, this array. Within this array, we are storing the pending updates, right? So I had mentioned while explaining that one. So we will combine the results of the children and we will add any pending lazy updates. So I can write in this way, data of lazy. So here, this will be, and just make use of func. This will be function. Data going to index. So this is fine. Also, again, I'll just consider this dot data within this one 2 into index plus 1. So somewhere I did wrong. I don't know where I did wrong. So here somewhere I did wrong. Just give me a second here. This one is the second one, right? So this has to be. So yeah, here this one, this bracket, this one has to be common bracket, not the this one, square bracket. So here this is fine. Plus finally lazy of index we will consider. So So again, so lazy of within the array will be considering the index. So this is, I hope this is clear. So after build, we will write the method to perform a range minimum query on the tree. So we have to perform the range minimum query on the tree, right? As we had discussed in the approach. For that one, we will write the method. So I'll just consider the name query here. I'll just give query of the parameter. I'll just take 2 parameters, alpha and omega. You can take anything. In my case, I'll just take alpha and omega. Let's initialize the result to default initially, nothing but we will be going with the infinity, right? So here you can see here, I'll just come here, we have initialized this one default value to the infinity initially, so we'll be going with the same over here. So I'll just give let result equals this dot default, nothing but infinity. After initializing the result to default, nothing but infinity for the minimum, we will convert the index to the leaf node index in the tree. So I can just keep here alpha equals alpha plus size, this dot size. This is fine. Next, for the end, we have to mark the end of the range. How can we write that? For that, I'll just be making omega equals omega plus this dot size plus 1. So here, this is fine. So the next step is we have to push the pending updates down to the current nodes in the specific range. For this, this I need to change, right? I'll just make use of the for loop. This one will be for let I equals, let's make use of the math.floor. Instead of the math.floor, I'll be going with the double tilde operator, so that this is somewhat faster compared to math.floor, right? I'll just make use of logarithmic 2 here of alpha. This is fine. Next, I has to be greater than or equal to 1. This is nothing but reverse iteration, what we are doing here. So then we will push, what will push? Alpha, right? So alpha I. So this is fine. Next step, what we will do, let me come here. Let me write another for loop. Yeah, this will be, instead of the math.floor, again I'll be going with the double tilde operator. Let me make use of math.logarithmic 2 here, omega minus 1. So this is fine. Next, I greater than or equal to 1. Finally, we'll decrement the, nothing but the reverse iteration over here, right? So here I can just give this dot push of omega minus 1. So this has to be omega minus 1. Finally, this will be I. This is fine. So what we have done here, we have pushed the pending updates down to the current nodes in the particular range. So after this step, let's traverse the range and collect the minimum value. We have to collect the minimum value. For that, we need to traverse the range. So alpha has to be less than omega for this particular thing, right? So this has to be true at at any cost. So for as alpha has to be less than omega, then I'll just make use of the this one. While loop, I'll just go with if alpha less than omega, then I can write if alpha and 1. So I can write in this case the result, I can just give this dot func within the within the result I can just give res. So I can just consider data of alpha. I can just increment the alpha. So did I miss anything? No, right? So this is fine. Next, let me write same thing and let's make the necessary changes for omega. So I'll just copy the same thing over here. Instead of alpha, this has to be omega. Result has to be same thing, result, and this dot data of, instead of alpha, it has to be, we are decrementing omega, right? I'll just consider omega. So this is fine. Next, we have traversed the range, and we have to correct the minimum value as well. So I'll just give alpha, this one, I'll just set this one to 1. Omega, let me set this one to 1 as well. So finally, let's return the result. So nothing but we will be returning the minimum value in the range. I'll just go with return result. So this is fine. After returning the result, this is fine. Next, we will be writing the method to perform the range update on the tree. So we have to perform the updation, this one, range update on the tree, right? For that purpose, we'll be writing the method. And we also need to add the value to all the elements in the particular range. For this purpose, we'll be making use of the method update. Let's write this one fast. This will be update of alpha, omega, as well as value. So let's consider this one. Let's convert the index to leaf node index in the tree. So I'll just consider alpha over here. Alpha equals alpha plus size. So I can write this to size. This is one thing. Omega, let me consider this one. This one, first one, alpha, was we were converting index to the leaf node index in the tree. Finally, we need the end of the range as well, right? So for this one, we'll be considering omega. Omega equals omega plus. So I can write in this way, this dot size plus 1. So this is one thing. Next step, previous step was we'll be storing the original positions for rebuilding. I'll just give L. I'll assign this one to alpha, and R, I'll be assigning this one to omega. So this is fine. Next, let's traverse the range and apply the update. So I'll just be going with while alpha less than omega. So we can write in this type. So if alpha %1, so we can update the current node, as well as we can mark the update as pending for the current node. So this is almost same. Here, this will be data of alpha. So somewhere I have done wrong thing here. Why this is taking ALPH? Did I give somewhere instead of alpha? Did I take ALPH? Just give me a second here. Alpha, everything. Why this was showing the suggestion ALP? Oh, here. Yeah, this has to be alpha. Sorry. This dot data alpha, data of alpha plus value. For this, I'll just consider value. Hope this is clear. Next, we have to mark the update as pending for the current node. So I can just write in this way, this dot lazy. Let's increment the alpha here. Lazy of alpha plus value, right? So for this, I'll just write in this way. So next step is, after this, we need to update the current node and mark the update as pending for the current node. Here we are updating pending for the current node. Same like previous step, we'll be doing for the omega instead of alpha, right? So I'll just consider here. If so, let me do one thing. Let me copy this one entirely and make the necessary changes. Let me copy this one. Let me paste the same thing. So instead of alpha, I'll be taking omega and %1. This dot data, instead of alpha, let me consider omega here. We considered omega. This one has to be, we are decrementing omega over here, right? I'll just consider minus omega. This one remains same. And also here, this will be lazy. This one will be, instead of alpha, I'll just delete this one. Here, this will be omega. this one remains same. So same thing. After this one, let's initialize this one, alpha 1, also omega 1. So this is one thing. Finally, let me come here by space over here. So finally, we have to rebuild the tree from the left part, as well as we need to rebuild the tree from the right part. So I can just make use of the build of left for left. I'll just give here. For the right part, same thing. This dot, like I'll just be making use of the right, the final index. This would be for the right r minus 1. So I hope this is clear. So the next part is we are done with the propagation of the lazy, as well as we have implemented the segment tree with the lazy propagation. Next, let's start by reading the size of the array. So I can just give let n equals plus input. Here we need to move to the next line. For moving to the next line, we'll increment the count. After this step, we will read the array values and convert them to the numbers. I'll just give nums equals input of count plus plus. So this one. So within the same line, if we are having the distinct numbers, we need the space between them to read, right? So segregate. So for that purpose, I'll just make use of split, and also let's map them. This is of the type number. So I'll just consider a number. So you can consider a big int as well. If we are dealing with the large numbers of the large input, you can consider big int as well. For now, I'll just go with the number. So if we are getting the output wrong, or if we are getting the last two numbers, if we are having the decimal numbers, or if we are getting the last 2 or 3 digits wrong, then we can change this one. Then we can give big int here and try with the big int, right? So for now, I'll just go with the number. So after this, let's initialize the lazy segment tree within the input array. So I'll just take the variable name seg. Let's initialize the lazy segment tree here. Lazy segment tree of numbers, right? I have given nums, I think. Yeah, this is fine. So let's read the number of operations. We have to read all the operations, right? So I'll just give q equals, for reading, I'll just consider plus of input. We have to read individual lines. So I'll just make use of the count and I'll increment the count. So this is 1 thing. So next, let's process the each operation. So this is the last step. We'll be processing each operation, and finally we'll be displaying the result within the console. So that's what we will be doing here. So let's start processing each operation. For we are done with the initialization. Let's go for the iteration. So here this will be I equals 0, I less than n. So sorry. This has to be q. I have considered q, right? So q. Here, this one, q I have considered, right? So yeah, now this is correct. And then here we have to read the operations as the array of numbers. So again, same thing. I'll just write query equals initially input. We have to read all the lines, every line, line by line. I think for that I'll be incrementing the count. Again, if there are numbers, distinct numbers in the same line, then we need to leave the space. So I'll just make use of the split over here. So after this one, this is of the, we are making use of the number. So this is of the type number. So after reading the operation as an array, then if the query has 2 numbers, then it's an this one, RMQ operation, right? So for that one, I'll just be making use of if condition. I can just give in this format, if the length of the query, if it is equal to 2, then what I can do, I can just make use of this one, destructuring operator, L and R. I can just set this one to query, right? So this is fine. Next, if the range is normal, nothing but if LF is less than or equal to LG, as we had discussed in the approach, then we will perform the standard query. Or if LF is greater than RG, then we will be splitting into 2 queries, if you remember, right? So that was the logic. So if L is less than or equal to R, I'll just write if L is less than or equal to R, then what we will display, I'll just make use of console log over here. SCG I have to create. This one will be query of L comma R. This is one thing. This is fine. Next step is if the range is circular, nothing but LF is greater than RG, then we will split that one into two queries. So if we have made use of else, else what console, I'll just make use of the console. We need the minimum this one, right? So I'll just make use of math.min. Within the math.min, again same thing. So, dot scg dot query from 0 to R. We'll split this one into two queries, right? Again scg dot query of L comma n minus 1. So I hope this is clear. So this step is clear. Next, else what we will do, our main condition was if the length of the query equals is equal to two numbers, nothing but is equal to 2, nothing but if the query has two numbers. It's an RMQ operation as we have discussed. If the length is not equal to 2, then what we will do, I mean nothing but if the query has three numbers, then it is an NC operation, right? Then we can just consider this one for the three numbers. I'll just be going with L, R and V. So I'll just consider the destructuring operator. Here I'll just initialize this one to query. This is fine. Next, if the range is normal, then we will perform the standard update. So for performing the standard update, as we have discussed in the approach, this will be L less than or equal to R. Then what we will do, we'll just make use of the segment dot update, right? We have already written the update. So this will be segment L, R and V are the parameters. So this is fine. So finally, if the range is circular, then we will split again into two queries. So here I can write in this way, else. So nothing but if the range is circular, we are splitting this one into two updates, right? This is the final step. So this will be segment dot update. The parameters are which starting from 0, R and V. Same thing. Dot update of L comma n minus 1 as well as V. So we are splitting this one into two updates, right? So I hope this is fine. So somewhere I have missed something. I don't know what I have missed. So yeah, this is it. Let's see. I hope this is clear. So I'll just come here. Let's consider this input. We have to get the output 100, right? Let's check. Why am I feeling that? So yeah, somewhere I have done this mistake actually. Line number 76. Just give me a second. Let me come to line number 76. So this one has to be by this one in the array. We shouldn't be making use of array. This is fine. So unexpected identifier. So line number 82. Let's come here. Just give me a second. So yeah, what I have done mistake here is this bracket, right? I was feeling somewhere that I have missed the bracket actually. Misplaced the bracket. So I'll just cut this one. Let me put this one after here. This dot build. So here, this braces has to be, this bracket, particular bracket has to be here, not at the end. So I had missed this one. I was feeling this one. Somewhere I misplaced the bracket. So yeah, this is fine. Let's run this one again. So here and in the line number 14, I have misspelled this. Let me come here. Let's clear all the typos first. Here, this has to be, sorry. We are making use of this keyword, right? This is fine. Let me hit the run again. So here in the line number 14, new array. So this has to be capital A, right? Again, I have made the mistake here. Let's make this capital. So let me run this one again. Again, where line number 15, intermediate value, dot full is not a function. Here, where line number 14, dot full. Oh, this has to be fill, not full. We are filling this one with 0, right? So let me hit the run again. So here one we are getting again error at line number 40. So this dot data of lazy. Lazy is not defined. We have not defined the lazy. Just come here, line number 40, right? I'll just come here to the line number 40. Just give me a second. So yeah, first thing is here I have missed the in line number 39. This has to be index equals I have missed over here. And one thing is this is not lazy actually, sorry. This has to be index, right? So we are dealing with the index. I forgot. Here I have type lazy, I think. So this is one mistake. Let me hit the run again. So yeah, now we are getting the output 100. So there were some typos. So basically while typing, this is long, this one, right? Long code, right? While typing, I have done some mistakes. So I have corrected this one. So now this is giving the proper output. I hope the output is 100. Yeah, we are getting the correct output, right? So just give me a second. I'll just... So yeah, I'll just come here. Let me click on submit code. And this is problem C. Let me choose C, circular RMQ, and let me paste the code over here. So, and let me hit the submit button. So let's wait for some time. I hope this works. I hope this is correct. So yeah, let's wait for some time. Let's wait. So here you can clearly see this code got accepted, right? This took some time, but this got accepted. So this code works absolutely correct. So I had made some typos actually. There were some typos. I just wanted to clear those this one typos. So now this code works absolutely correct. And this is one of the best problems to understand the segment tree with lazy propagation. So I have explained whatever I know. This is it. Thanks for watching, guys.